What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. In this video, I'm going to be explaining to you what a variable length subnet mask is. Also, I'm going to be explaining the concept of a router on a stick. And then I'm going to be showing you how to put together what is called a VLSM chart, which allows for you to basically subnet IP addresses to assign IPs to various devices within a network that you control. So let's get into it.
All right, guys, so we have been learning subnetting for the past 2 or 3 videos in this Networking Plus certification class that I'm putting together. And some of you guys are probably lost and confused and wondering why we're doing this. Well, now I'm going to show you why we are doing this, to show you that these numbers actually mean something other than weird looking numbers written in a chart. So I'm going to show you guys a concept called a router on a stick. This is something that you will learn or apply if you go for your CCNA in the future or whatever the case may be. So the first thing you have is a router. It is represented by this circle with these lines going down the middle. It is connected to a switch, which is represented by this square with arrows going in opposite directions. And then hanging off this switch, you might have a computer over here, a computer over here, a computer over here, and a computer over here. Now in this example, all these computers can be on the same VLAN, or we can separate them to where these guys will be representing VLAN 2, these guys will be representing VLAN 3, and the switch by default is going to represent VLAN 1. And if you don't know what a VLAN is, it stands for Virtual Local Area Network. Basically, VLANs allow for you to logically divide a switch into separate networks. So VLAN 1, 2, and 3, these would all be 3 separate networks. And in order for a computer over here in VLAN 2 to communicate with a computer over here in VLAN 3, they would have to pass their traffic through the router, come back down, and then they could receive the message. If they were all in the same VLAN, VLAN 1, if this computer wanted to communicate with this computer over here, they would only have to pass traffic through the switch to get to the other device. But being that they have been logically separated onto one physical switch, they have to use a router. Why? Because routers connect networks to networks. So if you're a little lost and confused about that, I advise you to go back and check out some of my earlier videos that explains this concept. So now what we're going to do, we're going to talk about actually subnetting an IP address. So just imagine that this router, this switch, and these computers are all in the Tech G Corporation right now. And within the Tech G Corporation, we have paid for some internet service from Comcast or whoever else is out there, and they said, hey, this right here is your IP address that you are going to use for your network. So basically this IP address is essentially the public IP address for this router that is communicating with the devices owned by Comcast so that I can go out there and live my wildest fantasies surfing the internet. Okay. Now, within this network, I want to go ahead and subdivide this IP address so that I can allocate IPs for this device, this device, this device, this device, and any other device that I want. Now, within this example of the Tech G Corporation, I want to have sections. Now, currently Tech G doesn't make a lot of money, so all I can afford is a router and a switch, right? But I do have enough money to have a couple different departments. So let's just say that this is my marketing department over here, and this is my HR department over here. And we're all connected to the same switch. And we'll call this switch SW. And this is our router in case you need to see it. Now, I want the people in HR to only be able to access whatever devices are within the HR department. And I want the marketing people to only be able to access devices in the marketing department. So that's why these guys are in VLAN 2. These guys are in VLAN 3. But I also want them both to be able to communicate with the switch VLAN 1 as well. Like I stated earlier, in order for that to happen, you need to go through the router so you can pass traffic back and forth. Now, this IP address right here, 192.16.1.1. This is a Class C address. And if you guys recall, a Class C address is basically a classful IP address, and it ranges from 192 to 223. All right. So basically any IP address between 192.0.1.1 all the way through 223.255.255.254. That is what a Class C IP address is. So now, that is what the ISP has given me. They said, hey, this is your quote unquote street address for your router over here. Now, we all know with routers, if you've been paying attention to my class, you got a public IP address and you got your private IP address. And within the router, they perform this thing called NAT, Network Address Translation, so that basically you can quote unquote disguise all the IP addresses within your network. So when external networks are communicating with your network, the only IP address they see is this one right here. But now within this network, I want to go ahead and subdivide or subnet this network so I can allocate IP addresses to all these random devices over here in their particular VLANs. And the reason I want to do this is because it is going to make it much more easier and manageable to deal with a smaller collection of IP addresses. So we're going to go ahead and subdivide that. So before we get started, what we need to do is this. I need to first determine how many addresses do I actually need. So let's go to our marketing department over here. Let's just say our marketing department, I need 100 IP addresses for marketing. And then for my HR department, I need 50 IP addresses. And then for my switch, I need 6 addresses. And then for my router, I need 2 addresses. And this is my starting IP address right here, which once again is a /24 CIDR notation address or Class C address, right? So now we're going to go ahead and begin the construction of what is called a VLSM chart, or a variable length subnet mask chart. This is what's going to allow for us to get back over here and figure out what IP addresses we can assign to various devices within the network. So like I said earlier, we're going to need 100 IPs for the marketing department. We're going to need 50 IPs for the HR department. Our switch is going to need 6 IPs for whatever reason. And our router is going to need 2 addresses in order to make this thing work. And once again, our starting IP address is 192.168.1.1. That is our starting IP address over here. So let's go ahead and start constructing this chart. So first thing we're going to do, we're going to put what is the name column. Then we're going to have the number of hosts that we're going to need. We're going to need to know our incremental value, also known as our positional value. And I'll explain all this as we go along. We're going to need to know our network ID. We're going to need to know our gateway address. We're going to need to know our IP range. And we're going to need to know our broadcast IP address. And we're also going to need to know our custom subnet mask. And in some cases, this is more particular to CCNA, you may need to know this thing called your wildcard mask. But we're not going to worry about the wildcard mask at this present moment. So this is the chart that we are about to build, ladies and gentlemen. Now, before we go ahead and start building this chart, let me go ahead and show you a quick little way on how to go about figuring out how many hosts you may need and what the subnet mask may be and all that wonderful stuff real quick. All right, so here's a little handy dandy chart that you can put together real quick when you're out there taking your Network Plus exam, which is going to help you figure out what the hosts are and the appropriate subnet mask that goes with the host. And all you're going to be doing is using your power of twos chart. So you're going to put 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. You can drag this thing out, 2 to the 8th, 2 to the 9th, so on and so forth. But this right here represents your 4th octet. So from there, you can calculate how many hosts you're going to need. So 2 to the 0, well, that equals 1. 2 to the first, 2, 4, 8, 16, 32, 64, 128. And then from there, we can go ahead and figure out what our subnet mask is going to be using slash notation. So if you got one host right here, basically that means you're going to have a /32 for your subnet mask. Over here, you're going to have a /31/30/29/28, 27, 26, and /25. That's what your subnet mask is going to be. Now, if you want to know what this actually looks like in binary notation, basically this will look like this. You would just have the first 32 bits turned on, if you recall from my last video. So you have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So that's 24, 25, 26, 27, 28, 29, 30, 31, 32. What is that? 1, 2, 3, 4, 5, 6, 7, 8. All right, so all of them are turned on. I don't know why I didn't just put that together real quick. /31, same deal. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and a 0. So in the /31, basically you have 31 bits turned on. 1 bit is reserved for the actual host. Over here, you're going to need at least 2 IP addresses that are going to be used for assigning IPs to devices. And I'll explain all that as we go along. But basically, instead of you sitting around here drawing out all of your binary, you can just go ahead and remember this / notation in conjunction with the host, and that'll help you out and expedite this process a whole lot faster. So now let's get back to our chart over here. So like I stated, this is the IP address that has been assigned to us, 192.16.1.1/24. We need 100 devices that can have IP addresses for our marketing department. We need 50 devices for our HR department that can have IPs. Our switch needs 6 IPs for some weird reason, and our router is going to need 2 IP addresses. Now, when we begin this process, we need to start figuring out how to subdivide this network or subnet this network for the one that has the highest requirements, which will be 100. So we come over here, we put marketing, and we need 100 devices over here. Or 100 IPs, I should say. Now we need to figure out how many hosts do we need. So what we're going to do with each of these numbers, 100, 50, and 6, we're going to add the number 3 to all of these numbers. So 100 plus 3 is going to give me 103. 50 plus 3 is going to give me 53. And 6 plus 3 is going to give me 9. And the reason why we're adding 3 is because the 100, that actually represents the actual devices that are going to be assigned IP addresses within this little network that I set up over here. Now we're adding 3 because we also have to take into account for the IP address for the network ID, the gateway IP address, and the broadcast IP address. The network ID, this is basically the identification for this network right here. It's essentially almost the same thing as the main IP address that was assigned to us from the ISP, but now we are acting like our own quote unquote ISP, and we need to first and foremost identify the network that these devices are going to reside on. So that's how we get to the network ID. Then we also have to identify the gateway IP address. And the reason we're doing that, so when we're out here sending messages around, we need to tell these messages what is the gateway IP address that they need to go find in order for them to get out onto the wild internet or communicate with somebody else in another network. And typically your gateway IP address, at least within this setup, is going to be the private IP address associated with this router for this overall network. But within this little tiny network, we're creating a separate gateway IP address, which will be programmed into this router, but we're not going to go too far into that for this video because that's more of a CCNA related topic. But basically, we need that gateway IP address. So when I start pressing 1s and 0s and sending messages, these messages know, hey, I need to go find a certain gateway IP address so I can escape my network and go communicate with somebody over here or go talk to the router so I can get out to the greater internet. And then we also need to identify what is called the broadcast IP address. The broadcast IP address is essentially the last IP address before you begin the next network. And then everything in between the gateway and the broadcast is your IP range. This is where you will pull IP addresses from to assign to these 100 devices over here. And then the custom subnet mask, this basically identifies the portion of the network that all of this stuff is going to reside on. So we'll look at my previous videos where we're talking about this and I explain that in greater detail. In the wildcard mask, we're really not going to focus on this for this particular lesson. This is something that you'll need to know when you are going for your CCNA, and I'm just trying to keep this as simple as possible so that we can make sense of why we're doing this in the first place. So like I stated, we got 100 devices that need IP addresses for our marketing department, 50 devices for our HR department, 6 IPs need to be assigned to the switch for whatever reason, and then the router is going to need 2. And with the router, we're going to add another 2 to it, and I'll explain that when we get down to it. So 100 plus the 3, remember the 3 came from, we need to set up an IP for the network ID, the gateway, and the broadcast. So we need a grand total of 103 IP addresses within this network. Now, what we're going to do next, we're going to figure out what is the positional value or the incremental value for this particular network that we are about to construct. And we come back over to this chart over here to figure that out. So when I was telling you about the hosts, I put 1, 2, 4, 8, 16, 32, 64. Then I drew a line to indicate the break between octet number 4 and octet number 3. And if you were to keep dragging this power twos thing out, you would start this positional spot all over again and just keep going down the line. But basically, these incremental values or these positional values are essentially going to tell me what spot in the octet is going to fulfill my actual host requirements so that I can have enough IP addresses to allocate to my devices. All right. So we come back over here. As I stated, I need 103 IP addresses in total for this particular network. We come back over here to our positional values, incremental values, whatever you want to call them. And we're going to figure out what number does 103 go into without going over. So does 103, does it go into 1? No. 2, no. What does it actually go into? 103 can comfortably fit inside the number 128 without going over. Now, being that we need 103 hosts, that means we're going to be just fitting comfortably inside of the 4th octet, dealing with our positional value of 128. So we're going to come down to our incremental block, and we're going to put a 0.128 to indicate that we are operating out of the 4th octet, because that is what 103 comfortably fits inside of, ladies and gentlemen. Now we need to figure out what is our network ID. So remember, this is our starting IP address, 192.16.1.1. With this particular network, we're operating out of the 4th octet. So that means we're just going to zero out the last octet. So our network ID for this network is going to be 192.16.1.0. That is the very first IP address for this network, which is part of the extra 3 numbers that I added here. Our gateway address is just going to be one IP address above this one. So that's going to be 192.116.1.1. And then our IP range is going to be one IP greater than the gateway. So it'll be 192.16.1.2. I'm just going to go ahead and put a .2, and we're going to stop right there. Now we're going to go ahead and start trying to figure out our requirements for the HR department that requires 50 hosts. So we come back down here, we identify HR. We said we needed 50, but we're going to add 3 to get 53, because remember, we got to create an IP address for the network ID, the gateway, and the broadcast. And then we're going to go ahead and figure out our incremental value for this particular network. So we come back over here. We said we need 53 IPs. What number does 53 go into without going over? We see it goes into the number 64. And being that we're working out of the 4th octet, our incremental value is going to be 0.64. And now we're going to go ahead and we're going to figure out the network ID. So this is what we're going to do to figure out the network ID for the HR department. We're going to take the network ID of the marketing department and add it to the incremental value. So we're going to take 192.16.1.0 and add it to 0.128. Essentially, we're just going to be adding the 4th octet number. So 128 plus 0 is going to give us our starting network ID for HR department. It's going to be 192.16.1.128. That is our network ID for the HR department. Basically, this is the starting point for this network right here. And then the same thing applies with the gateway. It's going to be 192.16.1.129. Just one IP address greater than the network ID. And then our IP range is going to start off with a .130. Now, we can use this number to go ahead and figure out what is the broadcast number for the marketing department, because like I told you guys, the broadcast IP address is the last IP address before you start the next network. So all we're going to do is just subtract one IP address from the network ID of the HR department, and the broadcast IP address for the marketing department is now going to be 192.16.1.127. And now we can figure out the last IP address of the IP range where we can pull IP addresses from. And in this example, it is going to be a .126. So everything between 192.16.1.2 through 192.16.1.126, this is where we can assign IP addresses to all of the devices within the marketing department. And as you can see, this is a grand total of 124 IP addresses, I believe. That is enough IP addresses to cover our requirements of 100 devices needing IP addresses. Now we can come over here and figure out our custom subnet mask, and that is real simple. All we got to do is just go back and look at our chart up here. We stated that we needed 103 hosts. 103 went into the number 128, and that gives us a /25 IP address. And if you want to write this out in this binary equivalent, it's going to look like this. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, then 7 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8. All right, I put too many zeros on it. So that's what it's going to be. When written out in this binary equivalent, your subnet mask is going to be 255.255.255.128. So that is your actual subnet mask, 255.255.255.128. We just shortened it out and put /25. I mean, you can write it out if you want. It doesn't really matter. So there's another way you can figure this out for those of you who like math. So there's an actual formula for this. So basically the custom subnet mask, it equals the number 256 minus the network host. So 256 minus the network host equals the custom subnet mask. So basically you can just do 256 minus our network host, or our incremental value of 128 or 128. So 256 minus 128 is going to give you 128 over here. But since we're working out the fourth octet, it's going to be over here. So those of you who like math, that is a quick little easy formula. Custom subnet mask, 256 minus the network host, or the incremental value, I should say. And then that's going to tell you what your actual values are going to be for your custom subnet mask. Or you can do it the binary way, or you can just remember this easy little chart that I just showed you right here. Totally up to you. So now getting back to our chart over here. So we have pretty much solved all of our requirements for the marketing network. Now we're going to solve the IP address requirements for the HR department. So once again, we got 50 devices that need IP addresses. We add 3 because we got to account for the network ID, the gateway, and the broadcast. We figured out the network ID by taking the previous network ID and adding the incremental value to give us our current network ID, which then told us what our gateway IP address is going to be, which is just one IP greater than the network ID. Then it also told us our starting IP address, that we can start dishing IP addresses out to devices, and that's going to be a 130, which is just one IP greater than the gateway. So now we got that far. So now we need to go ahead and figure out the requirements for the switch. So we got our switch over here. I said we need 6 IP addresses for whatever reason. We're going to add 3. So that means we're going to have a host requirement of 9. We're going to go ahead and figure out our incremental value. So we come back over to this chart here. What number does 9 go into without going over? And we see it goes into the number 16 without going over. So that means we're working out the fourth octet still. So now we got a 0.16. So now we can go ahead and figure out the network ID. So we're going to take HR's network ID, add this incremental value, and that's going to give us the network ID for the switch. So 128 plus 64 equals 192. So our network ID for the switch is going to be 192.16.1.192. That's going to be our network ID. Our gateway is going to be 1 greater than the network ID. So 192.16.1.193. That is our gateway IP address. And then our IP range is going to start with one IP greater than the gateway. So that's going to be .1 194. Now we can go ahead and use this information to solve for the broadcast for the HR department. So we go to our network ID and we just subtract one IP address to get us 192.16.1.191. And then from there, we're just going to subtract one IP address from the broadcast to get our last IP address of the IP range, which is going to be 190. So right here, we're looking at 60 IP addresses that we can assign to the HR department, even though the HR department only has a requirement of 50. Well, 60 is enough to cover all to meet this requirement right here. And then also we can go ahead and figure out our custom subnet mask based off of our incremental value of .64 or our positional value. And we come back over to our chart. 64 is going to yield us a /26 custom subnet mask. So now we solved all this for the switch. So now we need to go ahead and figure out the requirements for the router. Now with the router, we got a requirement of 2, but we're going to add an additional 2 IP addresses for the router to come up with 4 total hosts. And why are we doing that? Because we need to account for the network ID of the router and the broadcast. We do not need to account for the gateway IP address. Why? Because the router is the gateway. So we come back over to our little chart over here. We need to account for 2 IP addresses for this router, the private IP address and the public IP address. That is essentially what we are accounting for in this overall network that we are constructing over here. Remember, the router by default, at least in this scenario, this is the gateway device. Everything is trying to find this gateway device so they can go out there and communicate with the internet, or this network can communicate with this network and vice versa. So that's why we don't need to account for a gateway, and we only need to add an additional 2 hosts to this. So now we need to go to our chart and figure out what does the number 4 go into without going over. So 4, it goes into the number 4 without going over. So our incremental value, since we're in octet number 4, is going to be 0.4. Now to find the network ID for the router, we're just simply going to add 192 plus 16. So our network ID for this router is going to be 192.16.1.208. That is our network ID for the router, because we simply took the network ID for the switch and added it to the incremental value 192 plus 16. We're in the 4th octet, is going to yield us a 208. Now we can figure out our IP range. It's going to be one IP greater than the network ID. So this is going to start with a .209. And then also we can use this number to figure out the last IP address of the switch. So we're just going to subtract one IP, and that's going to give us a .208. So that'll be 192.16.1.207. And then from there, we can just subtract one IP address, and that'll give us a .206. So all these IP addresses, that's a grand total of like 12 IP addresses. That'll meet all of our requirements over here for 6 IPs, or a grand total of 9 IPs. So we can, dish out IPs all over the place if we need to. And then we get back over here to our incremental value, .16, come back over here, 16 yields a /28 subnet mask. And now we're going to drag this thing out one more step so we can figure out this same information for the router. So we're going to take our network ID for the router, .208, and add 4 to it. And that's going to give us 192.16.1.212. We're going to subtract 1 from this miscellaneous network so we can figure out our broadcast. It's going to give us 192.16.1.211. And then we're going to subtract 1 from the broadcast of the router to figure out the last IP that's ending for this particular device. And that's going to give us a .210. So essentially 2 IP addresses, .209 and .210, that are going to be assigned to this device if we want. And then from there, we can also take our .4 and figure out what our custom subnet mask is. So we come back up to our chart. We see our positional value of 4 is going to yield a /30. And basically a /30 is a .252. So this will be 255.255.255.252 once you crunch out the binary and work its way all the way out. So in a nutshell, ladies and gentlemen, this is what a VLSM chart looks like when you are trying to subnet a network so that you can have IPs that are way more manageable to deal with when you are going through trying to subnet the network beyond just the initial IP address that you were assigned from your ISP. So in this example here, we have our marketing department. They represent VLAN 1 or VLAN 3 or whatever. It doesn't even matter. They represent VLAN 3. And we said we needed 100 devices to assign to IP. So let's just imagine that in this network, there are 100 computers hanging off this switch in VLAN 3. Well, from here, when we go through and start programming our computers to bring them to life, if we're doing this manually, these are the IP addresses that we are going to assign to these devices. So this device right here might be .2, and this one might be .3, .4. We have options all the way up to .126. For HR, we said we needed 50 devices to have IP addresses. So this is our HR department. So imagine there are 50 computers hanging off this switch in VLAN 2. We come to our IP range. We have everything from .130 all the way to .190, a grand total of 60 IP addresses. So this one could be .130 and this one could be .131 all the way up to 190 if we want. And then from so on and so forth. And then once we actually get inside of the computer, if we were to manually do this, it's going to ask you for the IP address, the gateway IP address for the network, and the subnet mask. So you would just easily come back to your chart. So let's just say we're programming up this computer. We give it the IP address of 192.16.1.130 because this is the HR department. Well, from this chart, we already know what the IP address for the gateway is going to be. And we also know what the subnet mask is going to be for this particular device in this network. And you would do the same thing for this one over here. And then you come over to VLAN 3, marketing. Like I said, we gave this one an IP address of 192.16.1.2. And then this guy will be .3. So if we go in here and manually program up these two computers, we already know what our gateway IP address is going to be. And we know what our custom subnet mask is going to be for this device so that it can properly communicate on the network. And then we also know what the information for the switch and for the router is going to be. Anyways, I just wanted to show you guys this real quick, even though it's probably been like a 30-minute long video or something like that, as to what all this madness means when we were going through subnetting, learning about classful subnetting, classless subnetting. Well, this is what these numbers actually represent when people start talking about subnetting. This basically allows for you to create networks inside of a grander network so you can easily manage this thing better, because yes, even though I have them logically separated on the switch, I might have another switch hanging off this router over here to create another little network. I could throw some firewalls up in here. I can get real funky out in these streets if I really wanted to. But this VLSM chart, this is what allows for you to create a manageable pool of IP addresses to deal with. That's why we go ahead and subnet this thing down based off of our specific requirements that we need for our network needs. So that is why we do subnetting in a nutshell, ladies and gentlemen.